Welcome to Gurobi webinar. Today's topic is about parameter. Find better solutions in less time through effective parameter setting. Here is the agenda. First, I will talk about introduction to parameters, including parameter type, and then I will talk about documentation and help about parameters, where you can find the documentation and the important chapters about parameters. Then I will talk about how to change parameter settings. And I will talk about interaction between parameters. If you want to tune parameters, there are some relationships between parameters you better know. And the important thing is about how to tune parameters. I will focus on very big models. I call million-plus models. I will tell you later on what I mean. And the reason for very big models often need a tune to get good performance. And sometimes, it is hard even for automatic parameter tuning tool. And you often need some manual tuning. Another reason, we are very confident Gurobi performs significantly better than other solvers for very big models. I will tell you the reason later on. Then I will show you what are the important parameters and how to use log message for the tune. That's not just for very huge model and also for other models. Then I will talk about automatic parameter tuning tool. And then last, I will show you one slide about suggested steps for hard model. First, introduction to parameters. Now, why we need parameters? Parameters can significantly affect performance. Let me give you two examples, LP examples. One model is from Mitman LP set. It's called LIM 520C. The size is reasonable, not too big, not small. It has some dense columns, not many. Dual simplex struggles take very long to solve it. Barely, even with crossover, solves it very quickly, less than 1 minute. And barely can handle it well if you only have few dense columns. And for simplex, sometimes it's okay, sometimes it's not. For this model, it's not. And another example is for social network application. It has a lot of variables, more than 30 million variables. But dual simplex solves it nicely, less than 200 seconds. Barely talks more than 2 hours. Not means barely is not good, but just the model is big. And now if you want to get good performance, for some model, barely perform much better than simplex. For others, simplex perform much better. Then you need a parameter to control. And for MIP, now you know LP is polynomial solvable. MIP is much hard. It's NP hard. Parameter can affect performance more on MIP than LP. So you will see we have much more MIP parameters. Another thing is parameter can significantly affect feasibility or numeric robustness. For example, now if you have a model, it's hard to know whether the basis where air condition has big kappa. We cannot predict. You maybe also cannot predict. Now, if it happens, then we have a parameter, for example, mark with tolerance. You can tighten it, and it will help. But for the tight value, it will slow down on most models. So that's why we need a parameter. Other is, users often have different goals. For example, now if you solve a MIP model, you get a value for a binary variable is 3.10 to -6. And for most people, it is okay, but for some application, maybe for some user, it's too big, and then you want to change it. And then we need a parameter to handle it. And also for MIP, often there are hard MIPs you cannot solve. But for many applications, if you got good solution, it's good enough. And we know for a lot of applications, 5% MIP gap solution is good, and most people accept that. So we need a parameter to control it. So you can see there are different type of parameters. One is about algorithms. I mean, we have simplex, we have barrier, we have MIP branching bound, and also we apply presolve to both LP and MIP. So, like for presolve, you have parameter aggregation. For simplex, you have pricing, and also norm adjust. For barrier, you have barrier ordering. For MIP, you have heuristic. For cuts, we have 10 cutting planes roughly, and for each cut, you have a parameter. And then you have tolerance. I mentioned earlier Markowitz tolerance and also integer feasibility tolerance. And you can have feasibility tolerance too. And for many applications, you cannot let it run forever. You need to have time limit. So we provide a time limit. You can set it to an hour. And we have other termination parameters like the node limit for branching bound tree. Others, you can have parameter to control whether you want to have log file or what's the name of log file, whether you want to have more display message or less. Now let me talk about documentation and help about parameter. Documentation. We have reference menu, HTTP format. When you install Gurobi on your desktop, and you can click Start button, you find Gurobi 5.5, and you click it. It will show reference menu. Then you click it, and then you can access HTTP documentation locally. Or you can go to our website to access, and go to our website, you can click resource, and then you can find the documentation, and then documentation has reference menu, startup, and others. And recently we also add PDF format reference menu, and you can go to our website, download it. And if you're using Python Interactive Shop, you can get some help. For example, you can first type help, and then about many different things. One is about parameter, then you can type parent help. We also have examples. One example called parameters, and there are different examples for different APIs. For example, parameter for C, for C++, and Java. And if you find the reference menu, there are two chapters about parameter. One is about parameter management and tuning. It's talk about routines like GRB2 model, and also the routines how to set and get parameters value. And the other chapter is about parameters. There are two sections. One is about parameter guidelines. It's divided into two subsections. One is about continuous models. It talks about important parameters for continuous model and how you can tune. And another section is about MIP models, and there are important parameters. Other section is about parameter descriptions. It lists all the parameters, and the first one is alpha field. If you click it, and you will see It has default value, min value, max value, and the description about this is for the aggregation, and if you do aggregation, you may increase the number of non-zero in the matrix, and this parameter is to control that, to limit it. If you use Python interactive shell, you can type help, and then we'll show you, and then how to get parameter help, and write parameter, and reset parameters, and then you can type para help. It lists all the parameters and has a short description. Now I like to talk about how to change parameter settings. First, I need to talk about environment. We use environment to store values for parameter settings. And for Gurobi users, you only need to create one global environment. In C, you can call Gurobi env to create a global environment. Although you can call the routine more than once, but it's not needed. Only you need one global environment. If you call it more than once, it may have some issue with license, for example, single-use license. So the short conclusion, you just need one global environment. Now I maybe have more than one models want to solve. I want to have different setting. How you can do that? We have model environment. To create model, you need a global environment to create a model, and the model environment will inherit the settings from the environment when you create the model. And now, if you have model environment, after you create the model, you change the global settings from global environment. It will have no impact on the model environment. Model setting, be careful. And we allow you, because each model has an environment. Then you can get the model environment, then change the parameter for the model. So if you do column generation, you have masked and submodels, then you can get masked model environment and the submodel environment, then you set different for masked model and submodel, then you can use in different parameter setting to solve them. Now I just show you briefly how you can set parameter settings, change parameter settings in C. And first is very simple. Create a global environment, then use it to create a model, for example, reading MPS file. And then important, you should get model environment, then use it to change the parameter. Because after model created, then change global environment. It has no impact on model environment. And now if you change the parameter setting in object-oriented API, for example, C++, it's similar. You just, first create global environment, and then you create a model, then get model environment, and then use model environment to change the parameter. We got a lot of support call. People are confused. They use global environment after model is created, then they don't see the change impact. And for the Java, it's similar. If you compare Java to the C++, you see Gurobi for parameter, Gurobi underscore, and for Java, Gurobi dot. It's very similar. So if you develop code calling Gurobi and supporting multiple languages, computer languages, if you want to port from one to another, it's very easy because our interface is very consistent. Now let's talk about changing parameter setting if you use Python interactive shell. And we provide more ways to change parameter. You can just type model.setParam and the method to 1. And it doesn't care whether it's integer, whether it's double. And another way is you just type model.parameters.method to 1. And we also provide you command line. You can use command line. You can specify the settings. Here, Gurobi _ CL space parameter name method equal to 1. Here, no space around equal sign. And then space, then next parameter name, simplex pricing equal to 2. Then model name. And we also provide you a convenient way to change the setting. It's using the file gurobi.env. For example, you call Gurobi and compile your code, whether it's C, C++, Java, .NET, or you use a Gurobi command line or Python interactive shell. And if you start it, when the code create global environment, it will look at the file called gurobi.env. If there is one, then it will look at them line by line, change the parameter. In the current directory, gurobi.env file. And the format is each line, it has parameter name, then space, then the value you want to change. And then here, second line is simplex pricing, then space 2. Then you change the simplex pricing to DevX. 2 means DevX. Now let me talk about interaction between parameters. There are irrelevant parameter settings. Here are 2 examples. If you're using command line, you first have method set to 1 and the bar order equal to 1 to solve a model. You know method to 1 means using do simplex. Then barely order has no impact. The second case, you using command line, set method 2 crossover to 0, simplex pricing to 2. Method equal to 2 means using barely, and crossover equal to 0 means no crossover. Barely without crossover has nothing to do with simplex, so simplex pricing equal to 2 has no impact, so it's irrelevant. But be careful, if you remove crossover equal to 0, then barely with crossover, it will use simplex, so simplex setting matters. Now let's talk about the relationship between parameters. Now, first I want to talk about feasibility tolerance and integer feasibility tolerance. Now let's just consider a very simple case. If you have a MIP, it has a very simple constraint, x less or equal to y, x is continue, y is binary. Now if you solve the MIP using default, you may get x equal to 10 minus 6, y also equal to 10 minus 6. Then constraints has no violation. But you have 10 to minus 6 integer feasibility violation. And if you don't like it, I think it's too big, then you may consider, tight the integer feasibility tolerance to, for example, 10 minus 9. And then you resolve it. You may get x equal to 10 minus 6, but y equal to 0. That looks good. So then no integer infeasibility. But you basically pushed it into constraint violation. So now constraint has violation equal to 10 to minus 6. So now if you want a smaller violation, you may want to consider both. They are related. That's you may want to know. And another example is about flow cover cuts and MIR cuts. Now if you solve a MIP, and then at the end we will tell you how many MIR cuts generate. Maybe you see it's slow and then generate so many MIR cuts, and then load relaxation or node relaxation are slow. And then hey, I want maybe try to turn off MIR cuts. But after turn off, then you see it generates a lot of flow covers. You may wondering why. Now I tell you why. Now consider a model. It has two constraints, maybe have more, I just listed two. And the first, it has x variables, and the second has y and z variable. X are continuous, y are binary, z is an integer. So now it has also verb for x variables. If you look at first constraint, it like flow conservation constraint, and the continuous variable has variable up, variable verb called controlled by binary, and it's perfect for generate flow cover inequality. Now our code by default will only try flow cover from constraint 1, and we'll try MIR cut from constraint 2 because it has general integer. And then if you turn off MIR, it will try flow cover on 2 constraints, on both. If you turn off flow cover, it will try MIR on both. So now you may, if you know that, you may want to turn off both. Or you maybe turn off both is not helpful. Maybe you can change the default value for flow cover. For example, set to 1. It's less aggressive, but still will generate. That may solve the issue. Now for Gurobi, also for the convenience, we also introduced meta parameters like cuts, for example. I mean, we have a lot of cuts. You want to be aggressive from all the cuts, and especially using interactive shell, it's maybe you need to type a lot. Now for your convenient, we just let you, for example, set cuts parameter to 2. It will be aggressive on all cuts, and set it to 0. It will turn off all the cuts. But be careful. If one cut is not at default value, auto setting, for example, cover cuts is set to 2, it's not default value, and you set cuts equal to 0, it will only turn off the cuts, those with the default value, but it still will be aggressive on cover cuts. And we also have another a meta parameter called MIP focus. And for a lot of users, hey, I just want to find a good feasible solution. Then you can set MIP focus equal to 1. It's meta parameter. It will set cut passes to 5, limit cut passes to 5. So less aggressive on cuts, more aggressive on heuristic. Set heuristic parameter to 0.2. Default value is 0.05. And then set variable branch to 1. That means use shadow cost. That's cheaper than using strong branch for pseudo cost. That's the default. And or you want to really prove optimality, then you can set MIP focus to 2. That will set cuts equal to 2, place off equal to 2, and we'll do more strong branching for pseudo cost. And we have other meta parameters like numerics focus, but not many. Now let's talk about how to tune. That's probably most interesting and most important. And we like to use, very bigger models. I call million-plus models. A million-plus model means it has at least 1 million constraints or 1 million columns. And usually you need to tune to get good performance because they are very large. And often you may need manual tuning. So I would say our reference manual has a chapter or the section called parameter guideline. It's still good for very large models. If you want to tune, you should look at. It's good for all models. And we did a computation on a Xeon machine. It has 12 core. We used more than just one because so many models and needed to tune. And we used one is Xeon computer with 12 cores, and other are equivalent machines. And the setting we tried for LP, we always try primal dual barrier with crossover first. If 3 are hopeless, then we will try barrier without crossover. But we don't try concurrent. The reason is memory issue and also cache issue. For the MIP, we always try using dual to solve root relaxation. That's default. And we also use barrier to solve root relaxation. And for each model, we try hard to find a better parameter setting if they are not solved quickly. Let's first talk about LP bigger models. Bigger LP models. Source. We able to get 33 public models, for example, from Mitman website or other site. You can find models like Count, PDE, Zip, TSP. We also get model from customers. I used 23 customer models about social network application, energy transportation, and we get more and more larger and larger model from customers now. And the largest one, we have 10 million plus models for PDE, 3 Zip, 3 social network, and 1 TSP model. And the largest one, the social network application, it has 42 million constraints, 111 million variables, almost 500 million non-zeros. The second model is TSP, 10 million city TSP model. And here are the computation. Now first column for the model, and the social one, because the sensitivity, I just name customer model, often using customer 1 to customer 21. And the second column is B time, barrier without crossover, the time. 7200 means that's second, 2 hours. And then BC time, that's barrier with crossover. D time, that's dual simplex time. P time is primal time. And the winner, we first compare 3 columns, BC time, D time, P time. If one of them solve it, then we pick the smallest one. This is a winner. For the first row, social one, the winner is D time. That's dual simplex win. And then if you look at the second line for TSP 10 million model, and all BC time, D time, P time, all hit time limit. Only barrier without crossovers is able to solve it. So we put Q bar. That means barrier without crossover. Now for the social one, and dual is winner, but we able to tune it and get better performance, speed up about 2x, little more than 2x. Then you look at the others, and for many, we are able to find a better tuned set, but for the others, we are not. But for something like custom model 3, do you solve it quickly, only 13 seconds, then I'm not bothered to tune it. And if solved less in 100 seconds, I won't bother to tune. And then you can see the time. Then go to next, and more results for the public model. For some reason, it's not easy to get tuned, better tuned setting. And only for TSP model, million TSP city model, I'm able to. And then more customer models. PDE, it's very hard. You can only solve with barrier without crossover. Crossover due primal or having trouble. Now I just show you one log about the largest model, social one, and as I told you, dual simplex solves it nicely. But if you look at the log, pre-solve take 967 seconds, and the total time is 1577 seconds. So pre-solve take more than 60%, about 60% of total time. So now you immediately, hey, can I reduce the presolve time? Yes, we have a parameter. Presolve equal to 1 means last presolve. Now if you do that, then presolve time is reduced to 254 seconds. Then overall time for simplex is not much changed. Then total time is 743 seconds. You are able to speed up by 2x, more than 2x. Now here is some summary about the winner. And if you see the winner, we have Barry win 15 with crossover, 15 without crossover. That means primal duo Barry with crossover are hopeless. And duo able to win 15, and primal is able to win 7. And one model is solved by presolve, although big. Presolve knocked it down to nothing. And the 3 models are hopeless. Now you can see most models are solved nicely. And you also notice, and our simplex is performed nicely compared with Barry. Barry now, because machine, the more improvement on the machine usually transfer to more speed up for Barry than for the simplex. And we're still doing well, and the reason is, I can tell you some reason. We start from ground up, and we able to, not many routing, we able to do careful profiling to speed up. Also, we got some nice idea how to speed up linear algebra for very large model and how to compute norm nicely. That's the reason. And also, later I mentioned this for the MIP. Simplex is somehow more important for large model, large MIP model, because the warm start barely can only use for root relaxation, and often you need, most of the time you need using dual simplex to handle a node relaxation using restart, a warm start. And we developed some good stuff, and you don't need to store the norm. You know, bigger model often take a lot of memory. If you store the norm, we know some other solver will store the norm, then you will quickly run out of memory. And let's continue. And for the tuning and the commands, now for the social one, as I showed you, if you reduce using dual and reduce presolve, and it's able to speed up by more than 2x. And for TSP, 10 million city, and I let the crossover finish. Crossover take more than 5 times than the barrier time. It's really difficult. And for the custom model 4 to 6, and it's similar to the social one. You need to use dual simplex and reduce the presolve, and you can speed up. But for model 14, customer, you need to be aggressive on presolve. You can speed up. And for custom model 20 and 21, if you look at log, barely solves them nicely, but it blow up in crossover. And then I tried some parameter like Markowitz tolerance, crossover basis, and crossover. I'm able to speed up crossover a lot. And then based on the computation, then you can see what are the important parameters for very large LP model method, whether using simplex or barrier, and presolve. And then if you have numerical issue, especially for crossover or for barrier, you may want to turn, tight Markowitz tolerance and try crossover basis parameters. Now let's talk about MIP million plus models. And the source, we get less public models, only 9 from MIPLIP 2010 for zip model. 1 is Neo server model. I think most also models have real application. And we also get 50 from customer model, and we get more. We continue getting more models, and have about is from energy and transportation and social network advertising. And the largest one has, we have 10 million plus models and 2,000 model and 5 customer model. The largest one has 7 million constraints, 24 million variables, and 49 million non-zeros. And here are the results. Now, first column, as usual, it's about model. Second, default. Default means using the do simplex to solve root relaxation. Root bar means using barely to solve root relaxation with crossover. We always need crossover, then we can warm start later solution. And then here winner, if you look at the for Hawaii model, default hit time limit, root bar hit time limit, then we using the gap to compare. And here gap using do is faster, the smaller gap. Then if you tune and you make place off, less place off, you are able to reduce the MIP gap in 2 hours significantly. And then if you look at model 2, customer model 2, and both default and root bar hit time limit, but if you look at log and barely able to have smaller MIP gap, actually do hit time limit solving root relaxation. And then if you tune, you're able to further reduce, really solve the model. And then if you look at these numbers, and you can see the tuned setting column, some need to be aggressive on place off equal to 2 for customer model 8. And then for 12, customer 12, you want to set MIP Fox to 1 and still using barely, and 13, 14, you using barely, and but set var branch equal to 1. And for custom model 16, you need to turn off the cuts to get good result. And here are more results. You can see place off is important. Sometimes you need to further reduce the place off time by set play pass is equal to 1. Or you set cut pass to 3, not very aggressive. But for some model, you need to make MIP Fox to 2 be aggressive. And here I show you one log on model customer 2. And you can see if you using default, I have the line with red color. The root relaxation do hit time limit, so you cannot solve it. And then if do hit time limit solve root relaxation, so you immediately, hey, we could try barely, then set method 2. And then you not solved in 2 hours, but if you look at the model, it has more constraints than variable. Now maybe it makes sense to solve the do formulation, set play do equal to 1 to solve the root relaxation. Then it's able to speed up a lot to solve the root relaxation. Then root is solved 226 seconds, and then it's able to solve the model in less than 2 hours. Now here the summary. The comment, we have 21 models we are not able to solve, and no feasible solution. MIP are hard, especially these very large models. That's not surprising. But for 43 models, we are able to solve or find a good feasible solution. And if you look at using root barrier to solve root relaxation Win 13, default do solve root relaxation Win 30, much more. That's why, unlike the other solver, because our do simplex perform quite well. If you look at the benchmark for large model, benchmark for LP only about larger model. Smaller model is solved too quickly. And we are good. And we are good on do simplex. That's why, our default is still using do simplex, and some other solver using concurrent. But I mean, for root, concurrent may be good, but then you still need to solve node relaxation using do. We have good technology. We don't need to store norm, and we have an advantage and has less chance to run out of memory. That's why I said we are confident Gurobi perform better than other solvers for very large models. Now let's back. So for root barely found no solution only on 2 models, but root do found no solution on 8 models. And for most of these 8 models, do is unable to solve root relaxation. So still for many models, you need barely to solve the root relaxation. And if you look at the computation I showed you, 3 pages, 3 slides, and you can see some important parameters. MIPFOX, pre-solve, and then the cut path is variable branch, and methods, yes, and heuristic. Now let's talk about automatic parameter tuning tool. We had a webinar about Gurobi new release, Gurobi 5.5. It has, one-third is about parameter tuning tool. So I will go a little bit fast. If you are interested in, you can still go to our website to look at it. So what's the goal? To design the parameter tuning. And you know the main goal, we want to find parameter setting with good performance. So we want to aim for largest possible improvement. And we have other goals. For example, you want to have smaller changes. Smaller change usually is better. It's less overtuned. And also we want real improvements instead luck setting. For MIP, you know, if you change it just a little bit, even just permute the columns, you can have very different performance, maybe more than 100x. If you just permute the columns, we want to limit the impact of randomness. We will show you later. And then for user, some user maybe want to tune quickly. I want just tune for an hour, and some user have the time to tune more. They could have like 5 days or overnight, even more, 5 days. Now, what we designed is we tune fast, but we also still will explore a larger space of parameter settings. So what we do is we will first favor most promising parameters and be smart about parameter interaction to eliminate bad combination. And so if you run not long, still you could get interesting result. If you run it really long, we will explore bigger and bigger space of parameter settings. And for tuning tool itself, we have reasonable default. For example, tuning time for baseline run is an hour, but we also give you a lot of control too. I will show you later. So now for parameter tuning tool, now we have 2 different interfaces. One is command line here. You can just type Gurobi method equal to 1 model. Now the first parameter setting means using do simplex. So this is fixed in the baseline. Then all the tuning set will use it and then try and we output. And we also have the API interface called model.tune, and you can use that. Now how we do? We have 2 phases. We have baseline. Usually using default. If you don't specify baseline settings, then we use default, then run for example, an hour and set time. If it's solved in less than an hour, then we will change the settings and let others beat. Besides, we will gather statistics about where the time spent. For example, most of the time on the pre-solve, then you will change the parameters pre-solve setting to be less aggressive on pre-solve. and then we will do search, and then consider different parameter setting. We always keep track of the best setting found, and then you can control the tune time limit to adjust the search time. For example, you want just to do for 2 hours, or you want to do for 5 days. And the baseline, like for MIP, we will do 2 baseline by default. As I said, for MIP, often randomness is an issue. If even you just permute a column, you may get totally different performance, maybe 100x difference. So now what we do, inside the code, we have some part where sort. Then you have the seed. You try to control the sort. For the different seed, its sorting result will be different if there are ties. And then you can reduce the impact of randomness. And if you think my model is not that unstable, then you can reduce turn try to 1 if you think it's not stable model, and then you can set it to bigger number, for example 5. And then you can use parameter change that include in baseline run and search runs. For example, you don't like violation too big on integer variable, you can set the integer feasible tolerance to 10 to minus 9. Then when it search, always we're using the tolerance equal to 10 to minus 9. Here are a parameter tuning search result, intermediate result. For example, for MIP model MISC07, and then you run it, then you see, and it will show its try parameter set 9, you list 0, MIP Fox 1, and then you using 2 seeds to solve. 1 seed is slightly over 1 second, the second seed slightly less second, then you combine them, compare with baseline, then it's better. Then it will show improvement found, and it will also tell you total elapsed tuning time and what time remaining for the tuning. And then here is the final result for LP model PDS 100, and the baseline it take about 42 seconds, and the improved setting you can see method equal to 1. It takes slightly more than 30 seconds, and then you remove some pre-solve, be a little more aggressive on pre-solve, then you increase time a little bit, and you remove more, increase a little bit more. You can see here mainly method equal to 1 matters. That means using dual simplex. And we, for the MIP, for the tuning, we will return an efficient frontier and trade off between number of parameter change and achieve the runtime, like best result for 3 or less changes, best result for 2 or fewer parameter changes. And you can obtain more results by modifying the tune result parameter. And when finished, GRB tune will write best parameter choices and associated logs to a set result file. Now here is the final result for MIP model MISC07. Baseline run is more than 2 seconds, 2.42, and improved set slightly. First improved set less than 1 second. You can see you list off MIP Fox to 1, and then second with less parameter change, and then third just turn off the rim. Now we have tuning criteria, and we have 2. One is minimize runtime, and if you cannot solve, then we use optimality gap. And if default cannot solve, then we use optimality gap, and whenever a set we found can solve, one switch to minimizing runtime. And you can also, using tuning, to tune multiple model, find a settings good for a set of model, and you can minimize total runtime or minimize mean gap. And interesting, you may want to ask, if you're using tune, how much speed up you could get. we did a test with 423 MIP model, not very hard, solved by default 1 to 10 seconds, and we let tuning tool run for 500 seconds. I mean, it's just hard to run hard model because it takes too long. And then we got mean improvement, 2.91x speed up. And I'm sure for hard model, if you run wrong, it will have bigger speed up. Now I have the last slide about suggested step for hard models. And now, first, you need to make sure if you are not happy, you need to have fast computer. I mean, especially for Berry, you need to make sure using Intel chip i7 or most recent Xeon chip. Now, then try automatic tuning tool first, and then you look at the result and to see whether you are happy. If not happy, then you maybe look at the result and do some manual tuning, and you can look at the parameter guideline. And then if needed, you can retry tuning tool, add some baseline, some parameter as baseline. If still not, you maybe try branch priority, and most likely it may not help, but it won't hurt to try. If still issue, then you may need to reformulate model. For example, look at matrix coefficient range, reduce them, and use fewer general integer variables. And you may want to look at book like H.P. Williams, model building in mathematical programming. And if you still have issues, you feel free to contact us for support. And if still hard, you may consider heuristic cut callbacks. Any questions?
Thanks, Dr. Gu. Yes, this is Greg Glockner here. I'm going to be the moderator for the questions and answers. So if you have any questions, please type them into the question and answer box, and I'll be sure to ask them to Dr. Gu. While I wait for more questions from the audience, I do have a couple to get started. First, when you were on slides 12 and 13 and you were talking about the model environment and the master environment, could you explain a little bit more of why there are two different environments for setting parameters in the solver?
Okay, so I mean, because for some issue, for example, license, it's always better just to have one global environment. But some people want to use different parameter setting for different model. Like column generation, you have mass model, it's different than submodels. I mean, often different parameter may work better for different models. Then you need to have the setting. The model need to have its own setting or environment. Do I answer the question?
Yes, I think so. Thank you. I've got another question here. The question involves MIP starts, and the question is, how does it help when you provide a MIP start? How does that help in solving a MIP problem?
So that's an interesting question. I usually provide a MIP start will help. And actually, we did some tests internally. We just solved the model, write out optimal solution, and then feed the optimal solution, and then solve it. And the mean speed up is about 2x, not too big, 2x. For some model, it's bigger win, but there are some model, it actually got slowed down. So MIP sometimes always randomness are involved.
Okay, thank you. If any of you have follow-up questions, if the answer doesn't completely answer your question, just be sure to post it into the question and answer box on the GoToWebinar control panel. I'm going to move on to the next question. And the next question is, can you comment on the role of the heuristic parameter in solving a MIP model?
So for heuristic, I know for a lot of application, find the solution early is important, very important. And you can, I mean, we have heuristic parameter, that's good. You can, I mean, default value is 0.05. You can set the value high, then it will try aggressive, find the solution early on. Or you can have MIP focus parameter, set it to 1. That also will help. But for some model, maybe still not help. We have some expensive heuristic called like zero objective heuristic and mean relax heuristic and the pump passes for feasibility pump. You can try those heuristic. And I mean, for a lot of models, they help, but they could be expensive.
Yeah, thank you. Sorry, I'm going through the list, and I've got to the next question, which is the writer says, based on our experience, it seems that the default setting is always better considering the different data inputs. Is that true most of the time, or when is it that the default settings are going to be better than tuned parameters?
You know, we always try hard on the default setting. Hopefully it will work well on the all set. And that's, I mean, certainly we try hard, but it's not always the case. You can see I present the tune result, and you see we able to using automatic tuning tool on not very hard model with the speed up is 2.91. So we try hard to improve default setting, but still, I mean, MIP is hard, and then if you want to get better performance, you may need to tune.
Thanks. Let's see. Next question is, I've seen very good performance on the heuristics when solving large MIPS, even finding up to 90% of the solutions, meaning most of the solutions are coming from the heuristics. How do the heuristics work, and how do they interact with other parameters?
Now, how it work? I mean, we sometimes, I mean, we like inform meeting. We have workshop. We talk about what we do inside the code. Talk about heuristic, and for example, most recent one we talked about network simplex type heuristic to improve the solution. And we often talk about what we do, but it's hard just, I mean, like the QA section, I mean, talk about what we do. It's a little bit hard, and we will welcome you, I mean, join our like workshop, or we can give you more detail what we do with our code. And if you have more detailed question, I should able to answer you better. Thank you.
Thank you. Next question. When you run the tuning tool for, say, 1 day and you don't find any improvements, can you continue solving to look for more improvements?
That's certainly possible. If you run 1 day, you cannot find better, and the model is still not solved, or you still not happy with the performance, you could let it run for 5 days. Then the chance is getting smaller and smaller. As I said in the last slide, then if really issue, you can, I mean, contact us for support. Feel free send us the model, and we are happy to look at, and we certainly have more information about how it's code perform. Or, I mean, for some model, we maybe also have difficult, and then you may need to consider heuristic or cut callbacks.
Thanks. Let me just make one comment back to the questioner on that one. So in addition to what Dr. Gu said, you can't continue the run if you wanted to do additional testing, but what he said was true, that you may have reached the point of diminishing returns. It would, of course, depend on the difficulty of the model. Obviously, a model that takes a few hours, you wouldn't do that many tests in 1 day. Okay, next question, also involving the tuning tool, but this comes from a different person. The question is, when you run the parameter tuning tool, the log file provides the values for after solving the model. Do you have to then set the manuals the parameters manually when you solve the model again?
So, I mean, if you have the code call, I mean, using C++, and often, I mean, it's convenient. You just write out the model, then use command line to tune. Then you find the setting, then you need manually, I mean, port this setting to, I mean, your code. For example, if you're using C++, it depends how you do. And or you can use in the API called tune. and then after tune, and then you get the parameter setting, you query the change, and then you just set them.
Thank you. I'll get to the next question. Other than setting the Markowitz tolerance, what options do you have for handling numerical issues?
We have numeric forks, that kind of meta parameter, and we set several things, and you can, set it 1, 2, 3, and 3 is the highest. Very careful. It will, using quad in simplex, and it will set Markowitz tolerance very high value, and there are some options there. Sometimes you may need, because, your coefficient is too big or objective is too big, we have like object scaling, or sometimes you should try scaling parameter. We have a talk and a video about numerical hard model. Greg, you give a talk, that's right. Still, you can find from our website. Just feel free, go there and download it and watch it.
Yeah, that is correct, although I think you are right that the numeric focus parameter is new since that talk was prepared, so that is a new feature. But you're right. Beyond that, the other tips can be found in that other presentation. Thanks. Next question. We still have a whole bunch, so let me try to get to them as quickly as possible. Next question is, does the heuristics parameter override the MIP focus parameter?
Yes. The rule for meta parameter, like the MIP focus, always individual parameter will override. If it's not at default, then it will use that value. Instead, set to, using meta parameter to set to a new value.
Thanks. Yes. We still have a large number, so let's try to get to them as so we can make sure we get everybody's questions here. Next question is, are there any parameters to help re-optimization in continuous models, LP and QP, like when you need to solve several QP problems while gradually changing the objective coefficients?
Now,
any parameters that could to help that?
Yeah, for example, if you solve LP and then solve one LP, you change the objective and you resolve, and our code will use basis to warm start solving. And the default is still using dual simplex. It's hard to predict whether dual will be better than primal. In case changing objective, it's really, we did some tests. It's kind of half chance dual will be better than primal. So I would encourage you just to try using primal to see whether it helps. And that's for LP warm start. For MIP, because mostly you can do is using MIP start. Not much to do with parameters.
Okay, thank you. Next question involves multi-threading. Are there any tips or tricks to with MIP to make better use of multi-threading?
It depends. We use less. We often use just one thread for root. Now it's not quite true, but it's, sometimes root is too expensive. Then you maybe, for example, you want it using more threads, you can change the cut passes, less cut pass, immediately go into, parallel branching bound, and sometimes help. And for some very large models, and then if you're using, for example, all the threads or 4-core, then it's memory issue, cache issue. Sometimes it's just using one thread is better than, just the sequential is better. And it depends. And then for the root is harder, you using barrier, then you could use multi-threads to solve relaxation. It's hard to say, and sometimes it's luck. Even you using one thread is faster than using 4. It happens, but most of the time, using more threads, it helps.
Great, thank you. On slide 42, if you can go to that for a moment.
Okay.
There's a specific question about slide 42. When you talk about the speed up on this set of 423 models, is that speed up of a single parameter across the whole set of models, or is that individual changes for each of these 423 models?
Now for each we have, just each, not mean the single parameter change cause all these models have good speed up. Then we will change the default setting, that's right. Then actually for each model, and it may find a better setting than just record the better time.
Okay, thank you. Last few questions. Let's see. We've got two different questions. They're very similar, so I'll ask you the second one, which is that when you change coefficients on variables, that can make a big change on runtime. And so even if the rest of the model structure doesn't change, do you have any suggestions on how to make the runtimes more consistent?
Yeah, change the coefficient, certainly big coefficient, then the code need sometimes will struggle. Like simplex struggle, and then will hurt performance. And you make it small will help. But usually you should try, if you have bigger M, if you know some bound, and then you better using smaller one. But about consistent performance, I'm not quite sure about the question.
No, I think you covered that. Maybe some of the ideas of concurrent optimization could help as well.
Yeah, concurrent, especially like for LP, and you want, more consistent performance, you may want to use concurrent.
Great. I think the last two questions, first one is, do you have any suggestions for parameters that would help with degenerate models?
I think for this, if you're using simplex, using barely, degenerate actually is no issue for barely. Often is better, but crossover could have trouble. Then sometimes if it has trouble, then you may use crossover parameter, crossover basis parameter. And if you're using dual simplex and we have the parameter called norm adjust, that may have a big impact. And also we have a parameter called perturb. You can perturb, but then use that parameter to perturb, make it larger, then could help too.
Excellent, thank you. Last question is, can you run the tuning tool on a set of models to find a parameter setting that's good across the set of models?
Yes, we have the tuning tool works on the set of models. Then you can set the whether I think now the slides 41. You can give a list model and let GRB tune to tune. For example, like Bell 3A, Bell 4, Bell 5. If you run that, it will, if the code can solve it, all the model, for example, in 1 hour, then it will try minimize the total runtime and find the setting, one good setting to good for all these models.
Excellent. So thank you very much.
Thank you, Dr. Gu. Thank you, Dr. Glockner. And thank everybody for joining us today. We'll be making slides available, and you can see this page, the resources that you can also access right on our website.
Thank you. Thank you for attending the webinar.